In this video, we're going to look at an application of geometric series. A basketball has the property that each time it falls from a height of h meters onto a heart level surface, it rebounds to 50% of the height drop. That means 1/2 of the previous height. And of course, the reason is that this is due to frictional losses. As the basketball hits the ground, it loses energy due to friction. Now, assume that the ball is dropped from an initial height of 4 meters. Part A of the question, assume that the basketball continues to bounce up and down indefinitely. Find the total distance the basketball travels. Part B, find the total time that the ball travels up and down. Apply the fact that the ball travels a distance of 1/2 gt squared meters in t seconds. Part A of the question, as the ball is dropped from a height of 4 meters, it rebounds to a height of 1/2 times 4. And that's because every time it rebounds to 50% of the previous height, 50% is the same as 1/2. 1/2 times 4, that gives us 2 meters. So it rebounds to a height of 2 meters, then it has to drop down exactly the same distance they went up. So the ball drops down 2 meters and rebounds again to a height of 1/2 the previous drop height. So 1/2 of 2 is equal to 1 meter. The ball then drops down 1 meter and rebounds again to a height of 1/2 times 1, that's equal to 1/2 meter. This process of up and down bouncing continues indefinitely. Let's draw a diagram. So we start with the height of 4 meters. The ball drops 4 meters. It rebounds to a height of 1/2 of 4 meters, so it travels up 2 meters, and it has to go down the same distance it went up, goes down 2 meters, then rebounds to 1/2 the previous drop height, so 1/2 of 2 gives us 1, so it goes up 1 meter, drops down 1 meter, then it rebounds to 1/2 of the previous drop height of 1 meter, and that gives us 1/2, and then goes down 1/2 meters, and then, of course, the cycle keeps on going. It rebounds to 1/2 times 1/2, that gives us 1/4 meter, and it drops down the same distance of 1/4 meter, and then again it rebounds to 1/2 the previous drop height of 1/4 meter. 1/2 times 1/4 gives us 1/8 meter, then it drops down 1/8 meter, and this cycle goes on and on forever. So the total distance the ball travels, the total distance this ball travels is d is equal to 4 meters plus 1/2 times 4, because it rebounds 2 meters and 2 meters down, plus 1/2 times 4, plus 1/2 times 2, plus 1/2 times 2, because it rebounds 1 meter, then goes down 1 meter, plus 1/2 of the previous drop height of 1 meter, plus 1/2 times 1, because it travels down the same distance it went up, plus 1/2 times the previous drop height of 1 meter, the previous drop height of 1/2 meter, so that's going to be 1/4, then it drops down 1/4, 1/2 times 1/2. And the cycle just keeps on going. So the total vertical distance that this basketball travels up and down is 4. That's initially is dropped from a height of 4 meters, plus 2 plus 2, this part here, 1/2 of 4 is 2. 2 plus 2, that gives us 4. 1/2 of 2 is 1, plus 1/2 of 2 is 1. 1 plus 1, that's 2. Plus 1/2 plus 1/2, that gives us 1. Plus 1/4 plus 1/4, that gives us 1/2. Plus, and this is clearly a infinite geometric series. Starting at 4, that's the first term, and the common ratio, we can take the ratio of two successive terms. 2 divided by 4 is 1/2, and 1/2 is a common ratio. And even in the question we have that, it was given in the question that every time it rebounds to a height of 1/2 the previous drop height, so clearly the common ratio here is 1/2. But it's important to realize that the geometric series starts after the first term. So it starts after 4, and it starts at this term, which is 4 plus 2 plus 1 plus 1/2 and so on. All right, so it's clear that after the first term 4, we have a geometric series starting with 4, with a common ratio of 1/2. So the total distance traveled is d is equal to 4 plus 4 plus 2 plus 1 plus 1/2 plus 1/4 plus 1/8 and so on. So we have a geometric series. So let's write that. We have an infinite geometric series where the first term is 4, a is equal to 4, and the common ratio r is equal to 1/2. So d is equal to 4. Now this 4 is this 4 here. This is not part of the geometric series. The geometric series begins here. Plus a over 1 minus r. 4 divided by 1 minus r, which is 1/2. And that gives us 4 plus 4 divided by 1/2. That gives us 8. 4 plus 8 gives us 12 meters. We have applied the geometric sum formula. S is equal to a divided by 1 minus r. So initially the ball has, for part B, initially the ball has a height of 4 meters. To find the time that it takes for the ball to drop 4 meters, we're going to apply the formula that was given in the question. The height is equal to 1/2 gt squared to find the drop time. So let's solve for time. H is equal to 1/2 gt squared. And do a bit of algebra, solve for time. Time is equal to square root of 2h divided by g. All right, so let's find the time that it takes for the ball to drop down from an initial height of 4 meters. That's square root of 2 times 4 divided by 9.8, where the height is 4 meters. That's the initial height of the basketball. And gravity is 9.8 meters per second squared. So the total time that the ball travels up and down is t is equal to root of 2 times 4 divided by 9.8. This term here is the time it takes for the ball to drop down 4 meters, plus 2 times 2 divided by 9.8. Now, let's talk about this. Why do we have a 2 here? Because the ball travels up and it travels down. So we have to multiply the time that it takes to go up by 2, because it takes the same amount of time for this basketball to bounce up as it takes to bounce down and hit the ground again. And why is this 2? It's because every time it travels half the previous drop distance. Half of 4 is equal to 2, plus 2 times square root of 2 times 1 divided by 9.8, plus 2 times square root of 2 times 1/2 divided by 9.8, plus, and this goes on and on. It's an infinite geometric series. Now, something very important. When you're given a series like this and you're trying to find out what's happening in the series, always ask yourself what is changing. The thing that's changing is going to essentially be the thing that drives the geometric series. You can see this distance, this height is changing. We have 2, then half of 2, 1, 1/2. The other things don't change. Those are just constants. They're just constants that we deal with. But the main thing is find out what's changing, and that's what's causing the geometric series. So let's write this as t is equal to square root of 2 times 4 divided by 9.8. Now I'm going to factor out all the things that don't change. So that's 2 times square root of 2 divided by 9.8. Factor this out from every term that we see here, every term of this infinite geometric series. What remains is root 2 plus root 1 plus root of 1/2 plus root of 1/4 plus ... So clearly we have an infinite geometric series. So infinite geometric series with the first term, a is equal to root 2. This is the first term. And the common ratio, to find the common ratio, just find the ratio of the two terms. So root 1 divided by root 2, that gives us 1 divided by root 2. The ratio of successive terms gives you the common ratio. So now we can find the total sum. So t is equal to root of, so we have 2 times 4 divided by 9.8, that gives us 8 divided by 9.8, plus 2 root 2 divided by 9.8, times the sum of the geometric series. Well, the first term is root 2, so root 2 divided by 1 minus 1 over root 2. Applying the formula, S is equal to A over 1 minus R. So we have root 2, that's A, the first term of the geometric series, divided by 1 minus R, the common ratio is 1 over root 2. Now let's multiply top and bottom by root 2 and simplify this. So we get t is equal to root 8 divided by 9.8 plus 2 times root of 2 divided by 9.8. Multiply top and bottom by root 2 divided by root 2. And we're going to get 2 divided by root 2 minus 1. Now let's decimalize this. If we decimalize this expression here, we get 0.904 approximately, plus 0.904 times 4.828, and this is approximately 5.27 seconds. So the total time that this ball travels up and down is approximately 5.27 seconds. All right, thanks.